It's an evening in 1986. A young boy walks into his backyard in southern Illinois and looks up at the sky. Halley's Comet hasn't been around since 1910, but tonight he can see it with his naked eye. And it's in that moment he knows in his heart he has to be an astrophysicist. Unfortunately, the way we usually teach science does its best to smother this love and this sense of wonder in many of us. Take a look.
Today I'm going to talk about core collapse type supernova, known on the Minkowski's wiki classification scheme as types 1b, 1c, and 2. I will not talk about type 1a supernova, which, while useful as standard candles, undergo a somewhat different degeneration process. A core collapse supernova occurs when the iron core of a star undergoes photodisintegration. And through this process, most of the electron degeneracy pressure vanishes, and the core undergoes rapid collapse.
Excuse me! Hello! Yoo-hoo! Mr. Science Guy!
Yes, you have a question?
Yes. I thought you were going to talk about stars that blow up.
I am.
No, you're not. What does all that have to do with stars exploding?
Well, you first have to understand the collapse of a star in order to understand how it explodes.
Collapse of a star? We did not come here today to talk about Charlie Sheen.
No, I'm talking about nuclear fusion.
So nuclear fusion makes stars blow up?
No, actually, a star blows up when the core stops fusing.
When it stops fusing?
Yeah, it stops fusing when it runs out of fuel, and then that causes it to explode.
What kind of fuel? Gasoline? Kerosene? Propane? Ethanol? Biodiesel? Flubber? Dilithium crystals?
No. Superheated plasma.
Plasma? Ah, like in my new 50-inch flat screen.
Come here.
It's a very nice TV. It was on sale at Best Buy.
You know how an atom works? Nucleus in the center, electrons going around the nucleus.
Are you positive?
So the electrons are bound to the nucleus. But if they're given enough energy, then the electrons can break free of the nucleus, and creating free electrons and free nuclei, and that's a plasma.
I still don't get it.
You know, I don't think I can teach you. You don't know anything.
Oh, but I do know things. I know that stars are born. I know they shine for a long time. And I know they die. And I know that some stars explode when they die. And I know those are called supernovas. What I don't know is why they explode.
Well, gravity pulls everything inward. And all this fusing plasma creates pressure and pushes everything outward. Now, fusion creates energy, like burning fuel. But there's a limit to what a star can fuse. And when that runs out, the pressure inside the star drops, and gravity pulls everything inward, and then it explodes. You done?
But if you've used up all the fuel, don't you need fuel for things to explode? Like a car, or the Hindenburg, or the Death Star?
Yeah, the Death Star.
Yeah, it was full of energy, and it exploded with just one proton torpedo down the exhaust port.
Yeah, but it was even more cool in Jedi when they actually flew into the core and blew up the reactor.
Yeah! Mend your ships, and
may the Force be with you!
But I still don't get it. How can a star explode if it's used up all of its fuel?
Well, you see, that has to do with conservation of momentum and the collisions of ions.
You're doing it again!
You've just seen one kind of science lesson, a lecture. Yeah, that doesn't work. It doesn't lead to a deep understanding of science concepts and principles. It doesn't encourage conceptual change, and it doesn't lead to an interest in science, just an interest in getting out of the room. Lectures don't consider where the learners begin and where they want to go.
Fine. Let me show you.
Okay. Oh, look what. Oh, number 2. Here we come. So, what do these balls have to do with stars?
Well, we're going to pretend that these are iron atoms. That's what's mostly left over in a core when the star stops fusing. So the pressure inside the core drops. Gravity pulls everything inwards to the center. So if we pretend the stage is the center of the star and the balls of iron are iron atoms, watch what happens. And fair warning, this ball could go quite far.
Wow!
Did you see how far that went? That was your star exploding.
Wow! Let me try. Wow! Did you see that? That was sweet! Wow!
So, now you understand how stars explode?
Well, sort of. Kind of. A little. No.
Part 2, Brian did a demonstration. This was more effective. Kevin was clearly engaged. He wanted to make those balls bounce into the rafters. The problem with demonstrations, just because kids are engaged, doesn't mean they're learning. There's a lot of talk of hands-on science, but that does not guarantee minds-on science. At the end of the demonstration, Kevin still didn't understand supernovas.
But then what? Where does it all go?
Well, where can it go?
Out into space, where no one can hear you scream.
Okay, yes, but is it going to keep going on forever?
Well, sure. It just keeps going and going and going and going.
Think back to the bouncy balls. When the little ball bounced up, did it keep going on forever?
Well, no, it went out there to the first row.
So what kept it from going on forever?
Well, gravity. Duh. But there's no gravity in space.
No, but gravity exists between everything, even out in space.
No.
Yes, and you know this. The sun is in space, and it has gravity, right?
Well, yeah, because the planets move around it.
Right, and the moon has gravity?
Well, of course. I've seen the astronauts walk on it.
So, even the gas and dust from the exploding star has gravity. It's just a lot less.
So, if everything has gravity, then everything is attracted to everything else.
Yes.
So, everyone out there is attracted to me.
A little bit, yes.
Even her?
Well, yeah, but because I have more mass, she's more attracted to me.
Really?
So, all the gas and dust is attracted to each other and to all the masses out there.
Right. It's going to be attracted to where there's already a lot of stuff.
Yes.
Hey, I have an idea. We have a lot of big masses out here today. Now, if only we had something to represent the gas and dust.
You mean like 4 blue and yellow beanbags with stars on them.
Yeah, that'd be perfect. And how oddly specific of you.
It's almost like I had this plan.
So, if these are gas and dust, the exploding star sends them out into the universe to all the masses that is attracting them.
Yes?
So, one goes to that star right there in the second row. Yep. Oh, first row. Okay. And one lands on that planet back there in the third row. See him? Yep. Heads up. There we go. And one floats around that nebula right over there in the first row. See it? There you go. Ah, good catch. And then one collides with that moon over there, way on the end. Third row. Yep. Okay, first row. Okay. So, all the stuff in the universe comes from exploding stars?
Well, not the hydrogen and some of the helium that formed during the Big Bang, but everything else, yes.
So, all the stuff in our galaxy is made out of stardust. And all the stuff in our solar system is made out of stardust.
Yes?
And everything on Earth is made out of stardust.
You got it.
That means that I am made out of stardust too.
Yes.
And so is all of us.
And you just proved your world.
Part 3, Brian took off the lab coat, and he and the lesson were transformed. The third and best part of the science lesson, inquiry.
Inquiry is not the scientific method that you and I learned about when we were in school. It's the pursuit of truth and knowledge through questioning. It's an innate process that has built entire civilizations. It's, yeah. From an educational perspective, it's more than that. It's the development of process skills and the habits of mind that will enable our children to become proficient, lifelong learners. Now, we're not saying that factual knowledge isn't important, because it is, and it has its place. But it's more important that we know how to use that knowledge and that we apply it in order to generate new ideas and to solve the problems in daily living. So, okay then, think about this for a minute. We don't want to be the big people up here telling the kids what it is that they need to be doing, what they want to learn, what they need to learn. They already know. Kids know. If you know kids, they know what they want and they know what they need. Okay? They want to use their curiosity. They want to use their originality. They want human interaction in their learning. And they want to be successful just like you and I do. Well, we're listening to them because we're providing an inquiry model which delivers what the kids need and what they want. Inquiry is storytelling in science. It lets the kids tell their stories of discovery. It matches the educational process with the way kids think, focused on their world.
This is the age when those of us who look up into the sky with wonder are lost to a science education that fills our heads with facts and our hearts with confusion and disinterest. The show centers on real kids asking the questions that matter to them. And with the help of working scientists and a crew of human and puppet characters, much like you've seen here, the kids find their own answers. The bottom line for us is increased science literacy out in the community. We want to give kids, their parents, everyone, the skills, interest, and opportunity to prove your world. Thank you very much.